So 13.2 normal distributions. In math, in a more recent field area, we have an area called statistics. And statistics actually by mathematicians is not considered mathematics. It's more like an applied math. And so in statistics, oftentimes you're trying to figure things out on how to explain things to people. And it would be kind of nice if we want to know about what's the average weight of all teenage males. And we could add up every teenage male in the world and say this is the average weight, and that would be the actual value. But that would take a lot of time. So in statistics, what they do is they take a sample. So maybe they grab our classroom and go, oh, let's look at Ms. Joachim's Algebra 2 class, and we're just going to see all the males in there, get the average weight of the males, and that's what we're going to report out as the average. Okay, because we use a statistic from a sample. So today, kind of we talked about earlier, we're working with what we call a normal curve or a normal distribution. And they're kind of the same thing in a way. So in a normal curve, which I'm going to do in red here, we talked about this kind of a deal here where you have what we would call maybe a bell curve. And there's usually a mean and some deviations away from the mean. So in a normal curve, the mean is 0. And each standard deviation goes up by 1 and down by 1. And what we're going to learn is that data doesn't always come in zeros, ones, twos, and threes. Like for example, the weight of the people in here. There's probably not anybody in here who weighs -1 pounds. The average weight in here is not 0 pounds. And so later we'll talk about how do you change things so that it's what it's called normalized. So this normal curve is really representing some discrete data points. And when I look at those discrete data points, maybe like there's some different weights in here. And these are all points from our classroom. And what you would see is when you graph all of those points, if you were to cover them in a curve, you would see that this blue set of dots is a normal distribution. Meaning that if we were trying to model it, it would look like a normal curve. And the curve comes when you have an infinite number of data points. And so the curve models, bless you, what these discrete data points would be. So normal curve and normal distribution in practical sense just means this picture. Okay, they both kind of mean this picture. So don't freak out about that phrase, it just means the curvy thing. The mean in the past we've talked about as x bar. Today they use a different letter. They use this letter which they call mu. In general, like when you get to AP statistics, you'll learn that mu talks about population, x bar talks about sample. So on your calculator, when they talked about the mean, we did stat, calc, enter, enter. And when we did that, you saw like x bar, sx, all that stuff. This mu is the same as our x bar. Okay, so mu and x bar kind of is the same thing. In the next part, this standard deviation, the word that they use is sigma. And they have this little, it's hard to see, looks like this. That's sigma. And for us, that was really the same thing as sx in our calculator. And each one of these marks on that horizontal axis is the same as sigma away. So 1 is 1 sigma or 1 standard deviation away from 0. 2 is 2 sigmas or 2 standard deviations away from 0. -1 is 1 standard deviation but to the left, going in the negative direction. So it's 1 standard deviation below the mean. This is 1 standard deviation above the mean. And on our calculator again, that's the SX thing. Okay? Inflection points, which you're really not going to have to know too much about here. 2 things really. Number 1, probably the 2 most important things that is. Number 1, they occur where the graph changes curvature. So it's where graph changes curvature. And if that's not a word, I just made it up. So for example, in this case, notice how on the left side, I see the curve looks like this, kind of like a bowl. And then in the middle, it looks like a bowl upside down. And then on the right side, a bowl right side up. Where it's changing from the bowl right side up to upside down, that's an inflection point. And then again, when it changes in the other spot, and this graph is not really, I didn't do a very good job of being a perfect grapher. These things should be happening. And the second thing is that they occur at plus or minus 1 standard deviation. So if you're looking for where these things are happening, they're happening at the first standard deviation. And because I freehanded my sketch, my inflection points are a little bit off. Questions so far on any of the vocabulary? Zero is about the simplest you can ever get as a mean. Oh, you mean one, sorry, you said one symbol? Oh, because this symbol is representing that you're talking about the whole population. This symbol is talking about 30 kids out of this classroom. So if I said, tell me about every 17-year-old boy, this is all of them. This is a group of them from this school. So the symbols differentiate between the two kinds of things we're talking about. Yes, ma'am.
I still don't quite get normal distribution. Like, I kind of understand it's a part of under the curve.
Yep, normal distribution just means that when you look at a bunch of points, that they, if you were to draw them out, they make that bell-shaped curve. That's what it means. There are a couple things that I'm going to talk about how to do in your calculator, and I'm going to tell you most of the stuff that I'm going to show you don't have to do on your calculator. I'm going to show you how to do it with and without. So we're going to write some stuff down now, and then I'm going to show you how to do it in the context of a problem. So first of all, I'm going to talk about your window, and none of this is really going to make any sense until we do the problem, but it's going to be something for you to reference back at. So let's talk about the window really quick. First of all, in your window, which you're not going to do right now with your calculator, so don't worry about it, your x min is going to be equal to mu minus 3 sigma. Don't worry if this doesn't make any sense. It's going to be just fine when we do it in the problem. Your x max is going to be mu plus 3 sigma. Your x scale is going to be 1. Your y min, unless I tell you anything different, will always be equal to negative 0.1. Your y max will always be equal to positive 0.3. And again, this is unless I tell you different. And your y scale will always be 1. Right now, that might not make any sense whatsoever. Don't worry about it. I'll show you in a problem. Now, there's two things that you can do in your calculator. The first thing is if you want to graph a normal curve. So to graph a normal curve, it looks like this. Again, this might not make any sense until we do our problem, but it's a reference page only, like the formulas you have to memorize. So you're going to go to y equals, and you won't know how to do this until I tell you, but it'll be normal PDF, bless you, parentheses x, and then mu, and then sigma. And some of the things that you need to know is that the mu and the sigma are both numbers. And you'll see that when we do our problem. And this normal PDF thing, the way you get there is you do second bars. And I'll show you again how to do all this. Don't freak out about all this information. I'm going to refer back to this sheet. It's just so that you have it when we do it. Another thing that you should know is how to shade in this normal curve that you're going to be graphing. So, kind of the last thing I'm going to tell you about memorization stuff or things that you can do on your calculator is there's something called shade. I don't like this color, sorry. Shade norm. And there'll be a parenthesis that pops up, and then it's the number where you start, the number where you end, the mean, and the standard deviation. And you'll also have to get to this shade normal thing after you graph. And the way that you get to that is very similar to the previous one. You do second bars and draw. So second, hit the bars button, and then the draw button. Now I'm just going to pause for a little bit while people are getting caught up writing, and I'm going to tell you one more thing, and then we'll try some examples so that you guys can get a good understanding of what's happening. Yes.
What is the second bars and draws?
I'm not going to tell you until I do a problem.